Hi, welcome. This is second day on factoring. We're factoring quadratics. We're going to learn some new factoring strategies, but we're also going to practice what we learned in the last lesson. So remember the steps to factor for trinomials. Make sure your expression is in standard form, ax squared plus bx plus c. Factor out a greatest common factor, GCF, if you have one. I'm going to say other than 1. If there's a GCF other than 1, you want to factor that out because they always have a GCF of 1 if they don't have something else. And then find your values of A, B, and C. That's A, B, and C are the coefficients. So they're just the numbers in front, like the number in front of x squared is A, and the number in front of x is B, and the number that's off by itself is C. And then you find two numbers that multiply to AC and add up to B. And then you can either use the box method or you can factor by grouping. And let's take a look at what this looks like. So number 1, I look at that and I say, hey, they're all even. If I look at the smallest number, 4, I would want to see, now 4 will go into 8, but 4 won't go into 18. So so I go to 2, and I think 2 will go into all of them because they're all even. So I take out a 2, and that leaves me with 4x squared plus 9x plus 2. Because if I multiply 2 times 4, I get 8, and I multiply 2 times 9, I get 18, and I multiply 2 times 2, I get 4. So that's just a quick check. Now I look at what's inside the parentheses, and I'm going to see if I can find the values of A, B, and C here. A is 4, B is 9, and C is 2. And so now I look at AC. Remember that AC is A times C. And A times C is 4 times 2, or 8. And B is 9. So I'm looking for numbers that multiply to AC and then add to B. So 1 times 8, I'm just going to start with 1. I usually start with 1 because you can go through all the factors that way, 1 and then 2 and then 3 and so on. But 1 times 8 is 8, and 1 plus 8 is 9. So right off the bat, we found the numbers. Now, I like the box, so I'm going to use the box. Careful with the box that you're putting these numbers in the box and not the original, because we're just factoring what's inside the parentheses. And so we'll put 4x squared and then plus 2, the first one in the first box, the last one in the last box, and then 9x we're going to put in the box. Let's use yellow here. 9x, we're going to put that in the box using the two numbers that we found, 1 and 8. So this is plus 1x. You could also just write x and then plus 8x, because those two together, 1x plus 8x, is 9x. And so now everything is in the box that was in the original polynomial, not the original, but the second one after factoring out the GCF. Everything there is represented. So then I look for the greatest common factor for each row in each column. And this here is x, and this one is 2, and down here 4x, and down here 1. And then I just do like a quick check. 4x times x is 4x squared. Yeah. 4x times 2 is 8x. And x times 1 is 1x. And 1 times 2 is 2. And so then I can say that the factors 4x plus 1 times x plus 2, those multiply to give me the polynomial right here. But I need to remember I had factored out a 2. And so this 2,
Will the following students please come to the attendance office?
this 2 right here,
Rachel Yates,
let's use
Cecilia
this one.
Monteiro. Please come to
This
the
2 right here needs to come down there as well, and those are 1, 2, and 3 factors. 2 is one of the factors, 4x plus 1 is another factor, and x plus 2 is the other factor. There are 3 factors, and they multiply to give us the original. All right, example 2. I check for GCF. They don't all have ends. They're not all divisible by 2. They don't share common factors other than 1. So we checked. It's also a standard form. This is degree 2, degree 1, degree 0. So that's good. And then we can say that our A value is 2, B is negative 1, and C is negative 15. So A times C is 2 times negative 15, or negative 30. And B is negative 1. So I'm going to say 1 times 30 is 30. Now I need to decide where, excuse me, where do I put the negative so that when I multiply I get negative 30, but when then I add them I get a negative number. And I'm going to put that negative on the larger absolute value, negative 30. 1 times negative 30 is negative 30, but 1 plus negative 30 is negative 29. And that's not negative 1, but at least it is negative, the same as negative 1. So then I go to 2. 2 times negative 15, and that would combine to give me negative 13. No, not it. 3. 3 goes into 30. 3 goes into 30 negative, negative 10 times, and that would be negative 7. And that's not it. And 4 won't go into 30. 5 goes into 30. 5 times negative 6 would be negative 30, and 5 plus negative 6 is negative 1. Those are our numbers. So we go over here and we set up either the box or grouping, and say this is 2n squared minus 15 plus 5n and minus 6n. Using the 2 numbers here, make sure that you put the variable n with those numbers when you do that in the box. Because by so doing, you are putting in the equivalent of that middle term. Minus n, or minus 1n, is the same as minus 6n plus 5n. That's minus 1n, or minus n. All right, so now I factor. Greatest common factor for each row. This is an n here. Down here, I'm going to say minus 3. This first column, 2. 2n. And then over here, 5n times negative, or 5n and negative 15. The greatest common factor would be 5. And I think it would be positive. But now we're going to check the signs. We're going to check the multiplication. 2n times n is 2n squared. Yes. N times 5 is 5n. Yes. 2n times negative 3 is negative 6n. Yes. And negative 3 times a positive 5 is negative 15. Also yes. So our factors are 2n plus 5 times n minus 3. All right. So we look at example 3 on the next page. we're checking for GCF. I see all of these have an X, and they're all even. They're all divisible by 2, and so I can take out a 2x out of all of them. 2 times 5 is 10, and x squared. 2 times negative 12 would be negative 24, and then x times x squared. And then over here, 7. 7 times 2, 14, with the x is 14x. So now I look at the values of a, b, and c inside the parentheses. A is 5. B is negative 12. And C is 7. So AC is 5 times 7, 35. And B is negative 12. Now this time, I see my AC is, remember that we're looking for numbers that multiply to AC and then add to give us B. So the only way I can get a positive result is if both signs are the same, either both positive or both negative. But since B is negative, we know both of the numbers have to be negative. And if I just start with negative 1 times negative 35, that would give me positive 35 when I multiply them, but when I add them, I get negative 36. Not the numbers we're looking for. 2 won't go into 35. 3 won't go into 35. 4, no. 5, yes. Negative 5 times negative 7 would be positive 35. And when I add them, I get negative 12. Those are the numbers we're looking for. So once again, back to the box. 5x squared plus 7, and then minus 5x and minus 7x. And top row, I'm going to say they have a 5x in common. Bottom row, I'm going to say they have a 7 in common. First column, x in common. And then negative 5x and 7 seemingly have nothing in common, so that means they have 1 in common. If you don't have any other prime factors or variable factors in common, you always have the number 1 in common with all numbers and expressions. So now I need to adjust for the signs here. And I notice that this one, the top 5x is negative and minus 7 is negative. You want to avoid putting a negative on your leading coefficients x and 5x. So I'm going to adjust here. And if I put a negative on the 7 and a negative on the 1, when I multiply them, I get positive 7. So that's good. 5x times negative 1, negative 5x, yes. X times 5x, 5x squared, yes. And then x times negative 7 would be negative 7x, also yes. So my factors are 5x minus 7 times x minus 1. And then the 2x that I factored out at the beginning is also there, 2x. Now, occasionally I get asked, does it matter if I switch these around? No, it wouldn't matter at all. I could put 2x here and then x minus 1 and then 5x minus 7, and that would be just the same. It'd be fine. You can do that. The order of the factors doesn't change the result. So it's like saying 3 times 4 is equal to 4 times 3. And that is a true statement, as is that those two are interchangeable. You could also move the 2x. You could put the 2x as the second or third factor, and that'd be fine also. All right, example 4. Now, for example 4, if I said to you, hey, what if you took a plus b times a minus b, and let's look at that. This is what you call conjugate pairs. So you've got a and b and a and b, but then you have a plus in between one and a minus in between the other, and those are called conjugate pairs. And so if we multiply conjugate pairs, let's use a box real quick to see what that looks like. I put a plus b on the outside here, and then a minus b on the outside of the other one, and then I multiply them together. A times a is a squared. A times b is ab, and I'm going to just, for effect here, note that it is positive, so that's plus ab. And then a times negative b is minus ab. And negative b times a positive b is negative b squared. And so when I combine all these together, I add the products together. A squared plus ab minus ab minus b squared. These two in the middle are like terms, but they're also opposites of each other. So if I take ab minus ab and I combine them, they cancel each other out. And you're left with a squared minus b squared. Now this is called a difference of squares. This is a squared is a square and b squared is a square, and difference means that they're being subtracted. And so I've got a difference of squares, and when I factor them, if I go backwards, I get conjugate pairs, which means I can take y squared minus 9 and write it as something squared minus something else squared. And obviously the first one is y squared is y quantity squared is y squared. But then I say to myself, what squared is 9? And I put 3. And so that sort of tells me what my a values, my a value and my b value are. So a in this case is like y. So I can rewrite this then as y here and y here, 3 here and 3 here, and then I put a plus and a minus, and that is factored. All right, let's go through these. These are you'll like these once you get the hang of it. So example 5. All right, first thing we should always check for, and I didn't check for in that last one, but is the GCF. Y squared and 9 don't share anything in common. Y squared only has y's, and 9 is just 3 and 3. That's it. But example 5, we can factor out a 6. So I factor out the 6, and I get 6 times m squared minus 2. Oh, I'm sorry. Not only do they have a 6 in common, but they both also have m's. So I can take a 6 and an m out, and that leaves m here, and then minus 2. And that's it. That's as far as we can go. We don't have a factoring strategy for m minus 2. That's so that we leave it. 6m is one of the factors. You could say that's two factors, 6 and m. And then the other factor, or the other factor of the 3, is m minus 2. So that's it. That's factored. Let's look at example 6. Now, again, 9 is 3 times 3, and 4 is 2 times 2. They don't both have x's, but they're both squares. And so I can say, hey, this is something squared. Something squared minus something else squared, and the something that I put in here is 3x, and the something that I put in here is 2. And so now I know my a and b values. I can say, hey, this is 3x and 2, 3x and 2 plus minus, and that is factored. And you can verify that if you want by multiplying it out. You use the box or whatever method you would like to multiply those out. You would find that you would get the original 9x squared minus 4, which always works. And so this is just at the bottom. It says hint, definition of squares. Factoring when something is in the form of a squared minus b squared, where a and b are perfect square expressions, where the first term is a perfect square expression and the second term is a perfect square expression. The factored form looks like a minus b times a plus b. All right, and that's it. Keep practicing. Factoring is a little bit tricky when you're starting, but with practice you get better. So just keep practicing, and you'll do great. Have a good day.